I'm Pat Higbee, Energy Education Outreach Coordinator for the Center for Energy and Environmental Education at the University of Northern Iowa. For this Green Schools video series, I've invited experts to help you make your school more efficient, healthier, and a better place to learn, work, and play. Support for this video series was provided by the U.S. Green Building Council's Center for Green Schools, the Iowa chapter of the USGBC, and the University of Northern Iowa. This series was filmed at Iowa Communications Network Studios at UNI and other Iowa sites. It was part of the Spring 2011 Teaching with Energy course made possible with support from the Iowa Office of Energy Independence, Iowa Public Television, and UNI Continuing Education and Special Programs. We're very pleased to have some special presenters today who are going to talk about some real details. And so it's my pleasure to introduce these guys. So we have Scott Talbot. Would you raise your hand, Scott? There's Scott. We have Gary Caldbeck. If you'd wave, there we go, that's Gary. And we have Rick Wazell.
Retrocommissioning. Existing building commissioning is a schematic process for investigating, analyzing, and optimizing the performance of building systems through the identification and implementation of low/no-cost capital facility improvement measures and ensuring their continued performance over time. The goal of existing building commissioning is to make a building system perform interactively to meet the current facility requirements and provide the tools to support the continuous improvement of system performance over time.
And this is Scott, and we just want to hit on we're going to hit some reasons why and show some benefits and show some of the details. There's a lot of different ways in which you retro-commission and levels of detail, and we're going to kind of go through some of the procedures that we use. When we do our projects, we're more of a hands-on group, field abilities, and we carry equipment to take the actual measurements. And so we're going to step through our procedure and some of the things we've found to show you some examples. This slide is some examples of some things we've found. So we're stepping through why retro-commission. So what we did is we just picked a few things, and we'll talk about them here, but these are some pictures that we found from an actual school in our area. And what we're looking at is that the first picture is a low limit or a Freestat on an air handler. And the Freestat's meant to stop the unit before it causes damage, before a coil freezes and you have water damage in the building. Well, what happened here is this Freestat tripped on a daily or more frequent basis, so instead of fixing the problem, they just put a stick on it so they could walk in every morning and start the unit back up. So, and that's kind of some of the things we're going to show is these are things we found in actual schools, and we find this kind of stuff every day. And part of the reason is a lot of the schools and the staff in schools are so busy taking care of maintaining the school many times that they do not have the skills that are necessary to maintain and optimize an HVAC or a automated control system. And those systems are very complex. They're getting more complex as we strive to reduce energy, and it's something that has to be addressed, and that's why this is a real problem. Gary, you want to hit the next picture or two?
Sure. The one in the middle actually shows an actuator. It's a pneumatic device that opens a damper to open the outside air for the return air. If you look at it, you can see that the connector that would connect to the jack shaft, which is standing right up next to the duct, has actually fallen off, and it's poking a hole in the duct below it. It's actually broken, and it's been broken so long it's actually punctured a hole in the ductwork. So it can't open, it can't bring the fresh air into the school, which is necessary for students to learn. There's a direct correlation in the government studies that says fresh air at a minimum rate of about 20 CFM a student is required in order for students to optimize their learning process. So when you can't open it up to get the fresh air for the student, that's a problem. So, and this was actually found in a school.
Yeah, and the third picture there is just, it's a picture of a control panel. A lot of you may not be familiar, but it's a panel in a mechanical room that holds the controllers that actually control the amount of outside air, control the temperature of the units. And this one was so bad, it had been modified so many times, they couldn't even shut the door on it.
Why retrocommission? There are both energy and non-energy reasons. Sometimes you want to retrocommission just because you'd like to increase the performance of the existing equipment. Those three examples we showed you were pretty obvious. It wouldn't take too much to fix those pieces of equipment and get them to operate more efficiently. To reduce energy consumption and lower the bills. That's probably the number one thing we hear in buildings and in schools, is that they have a limited operating resource fund. Therefore, getting the bills lower by optimizing the use of the equipment correctly can lower bills, save money, and make more efficient use of the resources. Lower operating and maintenance costs. Schools operate on very tight budgets. Therefore, getting the operating costs down allows them not to be hit with unexpected bills, which can really hurt their budget. Improve indoor air quality and occupant or tenant comfort. If the student is comfortable, if he's got the right amount of fresh air, it's a lot easier for that student to be attentive. If you ever have Thanksgiving dinner and you have high CO2 levels and you feel like you're going to go to sleep, very difficult to learn in those situations. So, to improve indoor air quality, that's really big, I think, especially in these situations. LEED EB, we haven't talked about yet, but LEED for existing buildings is another reason to retrocommission. The cost effectiveness, everybody who's looking at retrocommissioning is interested in what is the benefit to me. It's fairly universally stated that you can usually find about 15% in savings without going too far in optimizing the equipment. The payback is typically somewhere between 6 months to 2 years, which means that it has an excellent ROI, return on investment. And if you talk to anybody who's the CFO or the financial guy for the schools, that's their number one concern. How fast do I get my money back? How fast does this start paying me for retrocommissioning the building? And the cost, of course, that's the key paramount thing that everybody wants to talk about. Usually it's in the vicinity of 20% in a school, or 20 cents on a square foot. However, if you get into labs or things that are much more complex, it can go up to $1 per square foot.
More reasons why to retrocommissioning. This is a study of the Lawrence Berkeley National Labs, the PECI, which is the Portland Energy Conservation Incorporated, and Texas A&M University. The top one there is ensure system performance, that's 69% of savings. Obtain energy savings is 94, and as you step down through this, they have relatively high percentages of savings.
The planning phase, it's getting a feel for the project, getting an understanding of what the goals are, what the owner's needs and wants and concerns are, and develop a retrocommissioning plan. The investigative phase is when we go out and take our equipment and we evaluate the current system performance and compare it to what the owner's needs are, and we make identifications of areas where we think improvements can be made. The third phase is the implementation phase. We normally, after we create the investigation or the baseline, we come back and say, what are we going to implement? What improvements are we going to make? And then when we do these, we actually come back and do a back check, or we verify the performance. And of course, in any successful retrocommissioning project, you have a turnover phase. This is how you educate the users so that they have a smoother transition as you hand it back over to the building staff, so they understand what changes you've made. Doesn't do any good to make a bunch of high-test changes if you don't inform the staff and train the staff so they understand how the building is going to operate going forward. And the last one is the persistence phase. It's really about continuous commissioning. Ensure continuous system performance is improved. So many of the building automation systems now allow you to trend them so that you can use a powerful system that can alarm and notify you when the building starts to degrade or the control systems begin to fade from where you've set them. And these things are very important in having a successful retro-commissioning project.
Okay, the next slide, this is LEED EB. We mentioned it a little earlier on a reason why to commission. LEED for existing buildings. And when you go through that process, it's basically to identify and get a grading system on your building. And a portion of LEED's a big process that involves several areas. What we're looking at here is the commissioning portion of LEED for existing buildings. And there are 6 credits available that relate to commissioning. And that's quite a bit in LEED. So what we wanted just to identify is if you do want to look at a LEED for existing building process to get your building certified, that if you go through a retro commissioning process separate from LEED, or if we go through a retro commissioning process for a utility to save energy, that same process may not be all 6 points, but a good portion of these points can be used in the LEED process. So that's something to keep in mind as you do retro commissioning. A lot of the work can be used toward LEED points if you decide to go that way. So that's really, I'll read them off. I'm not going to read the descriptions, but EA Credit 2.1 is investigation and analysis, which we discussed. That would fit right in. Credit 2.2 is implementation. You get points if you implement improvements that will save energy or create a plan to implement those improvements. And then the 2.3 is ongoing commissioning. So we put this slide in here to show you that the process that we're following in a retro commissioning, whether it's to save energy for utilities, rebates, it also follows the LEED process as well, and many things apply. So
This is a typical retro-commissioning findings. There's 20 findings. The first one had a considerable amount of kilowatt an hour savings, reduced equipment runtime, going down the list. The next one is the economizer operation. That's just below 5 million kilowatts an hour.
And that I'll jump in a minute, Rick. The very first one he mentioned, reduce equipment runtime. One of the things we're trying to point out here is low-hanging fruit. That things that are easy to do that save money, and that reduce equipment runtime. Really, all it means is you have building automation systems in your schools, and really all that is scheduling equipment. We go into a lot of schools where equipment runs 24/7, and it really does not need to. So anyway, sorry to interrupt, but that one is a low-hanging fruit that we're going to hit a little bit more of that later, but that's really what that means. And you can see that has huge savings.
That's a good point, Scott. As you can see, the top half of that bar graph is, like Scott said, it's low-hanging fruit that's has relatively high savings, not only in energy but dollar-wise. The right hand of this bar graph is a lot of things that may not have as much savings in it, but it does save energy and cost over time. So it's wise to look at the whole picture and have the owner consider all of them.
Right.
Yeah, so take advantage of that, and you can see that if you're on the left-hand side of the bar graph, and you look and you were looking for things that save a lot of energy, have a fast payback, you can identify those and take advantage of that information. There are simple things that you can look at that when you're going to look at a building that you would take advantage of to say, can I cycle these units off at night? Can I leave a sensor out in the space so that if it gets too cold or too hot, go ahead and start the unit back up, but let the unit only run for an hour or two before school starts and an hour or two after school is done. And then if it drifts too far from set point at night, in the summer or winter, it'll start the unit. But otherwise, leave the unit off and save the energy.
Right. And the other thing, just to throw in on this chart, the items on the left are the bigger energy items, so obviously those are the items that we want to hit first and take those out of the building, save the energy, show payback. Well, the items on the right are tuning the watch. We say, you know, first you have to get the watch running, and then we'll tune the watch. So that's really what we want to do is once you start a process, whether it's your own energy manager or you're working with an outside source to continue to save money, there's always options there to keep tweaking the system to save energy. This slide is general in nature, and a lot of these items can be applied to any building and any project. Reset duct static pressure, and this is on these items that I'm going to list here are on the air handling unit equipment. Pat mentioned we're pretty detailed, so these are detailed control strategies that we implemented on these projects to save energy, and these are modifying the air handling unit equipment controls to save energy. Reset duct static pressure, discharge air temperature, and what that means is as the building or the school or whatever the application is, as the space calls for cooling, the VAV boxes or the spaces open up and they try to deliver more cool air to the space. And what we do is the control system has the power to look at all of that and analyze, hey, my building's calling for cooling, let's put out cooler air from the main unit that serves that building. And the inverse happens on a heating call. As the building calls for heating, instead of having each individual room have to reheat 55-degree air up to 100 or above, we raise the discharge air temperature at the main unit in proportion so that it saves energy. Instead of causing all the units to heat, you heat some of the air at the air handling unit. So that's a simultaneously heating and cooling application that we're removing from a system. Same true on duct static pressure. Building static pressure control is something we did here, and this is when you walk in a building, then the doors are either standing open because the building's too positive, or you can't get the door open. It's tight, and that's usually the case. Buildings are negative. They're pulling in cold air, hot air, and unconditioned air, and that causes a lot of problems. So getting the building pressure under control is critical. VAV programming is variable air volume boxes. Those are typically the controls in a classroom. VFDs, variable frequency drives, is what VFD stands for. And what they had at this building, and I'm sure many of your buildings, is pumps, hot water pumps, chilled water pumps that run constant volume. They run 24/7, or even if they run 8 hours a day, they run at full speed, 60 hertz. Well, what a VFD does, you add a variable frequency drive and you can slow that pump down. The speed of that pump can modulate based on demand. Very similar to what we were talking about with the heating and cooling. If the building needs more pump flow, the pump speeds up. But if the building becomes satisfied, the pump can back off, and it saves a tremendous amount of energy.
When you were a little kid, if you remember putting your finger over the end of the hose If you blocked off 70% of the hose, you got a real fine stream of water, but you created a tremendous amount of resistance or pressure on your thumb. That's what's happening to those pumps. Those pumps are spinning using a large amount of energy and creating a small stream of water. When we put the VFD on them, we're able to open those valves all the way up, let the motor slow down, and save a huge amount of energy.
A lot of times the utilities will buy a project down. If we calculate that it's a 4-year payback on a project, the utility may buy that down to be a 1-year or 2-year payback. So anyway, there's a lot of incentives. With the utility dollars available in Iowa, it makes a lot of sense to look at these items.
So it's the responsible thing to do, and it's really nice to see the rebates because it encourages the building owner to go ahead and do these things, make these investments, and we think for schools who are institutional, they're long-term owners of these buildings, they're not going to turn around and sell these buildings in 10 years. We think it makes perfect sense to make these investments, especially when they have less than a 5-year payback, so that the school district can reap the benefits for the remainder of the life of the building. A lot of people would like to do a walkthrough audit, and they'd like to tell you all the things that they can save you. I always have trouble with that. I believe that creating the baselines that we've shown you by performing benchmarking and actually hands-on function testing the equipment gives us a much better ability to look at the performance of the building and evaluate it to say, if we do these measures, we can save this kind of money based on data, on facts. Scheduling is probably the #1 thing that you can't see when you walk through a building. Unfortunately, we find a lot of schools that are running more hours than they need to run the equipment. It's a double-edged sword. It cuts you because it costs more money to run it, and it shortens the life of the equipment because it's spent more hours running. So when you actually lower your utility bills by using scheduling correctly, you can actually increase the longevity of the piece of equipment as well as lower the bill. Moving too much air. Gosh, every time we go out to a job, especially in the past, oftentimes the equipment was oversized. It was decided for a design degree day, and it may be moving 15 to 20% too much air. When you slow those fans down and get them to provide the correct amount of air, again, you're saving energy. The example we looked at with the pumps, they were pumping too much water, so they restricted the valves. Anytime you do that, you are wasting energy. So opening those valves, putting the pumps on a VFD, slows the pumps down, saves energy. Scott referred to cooling and heating. You know, if the unit in the wintertime is cooling the air down to 55 degrees, and then we're warming it back up for the classroom, that's wasteful. So we should be resetting that discharge air temperature at the main air handler up warmer and warmer as it gets colder outside, so that we don't waste a lot of energy reheating that air. Simultaneous heating and cooling. I don't know how many times we'll go out to a job and we'll find the unit heating in the cooling mode, and the heating valve is leaking heat past it. So you're heating and cooling simultaneously, so that you're running the chiller and the boiler's on and the heating valve isn't closing completely, so you're putting hot water or steam into the coil, and then you're trying to cool it down with the chiller. Again, it's real obvious, but you can't tell it from a walkthrough.
This slide is continuous commissioning, how to maintain results, retrocommissioning results through continuous commissioning. And these are just a few examples of things that your building automation system can do, as well as your staff can do to maintain this. Because as everybody knows, if you make changes, you could be saving a lot of energy, but as years go by, if you don't continually look at the energy usage and the system to keep it optimized, things start to get out of whack and you would end up back to where you're not efficient anymore. So monitor and track the building's use of resources, and that's basically means metering. A lot of systems, if they're not installed, it's going to become, it seems to be becoming more of the norm that building automation systems have utility metering that they are monitoring so that you can see on a monthly basis and compare that to your utility bill. What are we using? When we adjusted this schedule, what did that do? What was the savings? So that you can continually tweak. Document changes through an operator's log, and this is just identifying, hey, I changed this schedule so that you know what happened. Fault detection, diagnostic tools, and that's really something that we've been doing when these automation systems are so powerful. You can set, they could be programmed to run a summary on a monthly basis of your variable air volume boxes. They can do a reheat summary and identify issues, simultaneously heating and cooling, airflow issues. They can run a summary and they can basically spit out a report that says, hey, room 301 has a problem, and it can, in some projects we're doing now, they're actually taking that result of that summary, linking that to their work order system, and it generates an automatic work order for the maintenance to go look at room 301. So that's where it's heading, and that's some of the ideas of things that can be done. And especially in schools where your maintenance staff is limited on their time. So staff training plan, that's making people aware so that your building people don't, you know, the fan is scheduled to shut off at 3 o'clock, but instead of actually going through the automation system, when there's an event on Tuesday night, they put that fan in hand mode and then forget about it, and now we're back to 24/7 operation. That's training so the staff operates the equipment the right way so that it's only on that one night.
So where's the low-hanging fruit in retrocommissioning? I think that's a really good question, because I think that's really the goal is in retrocommissioning. The first thing you want to do is pick the items that are comfort and energy issues that are going to save the most money. The number one thing we see is scheduling. We see units running 24/7 all the time when they shouldn't be. And I know this is going to make people kind of smirk, but we find units running 24/7 and they leave the outside air on at night, bringing in large quantities of outside air and heating and cooling it when there's nobody in the building. Obviously, if the unit was going to run in the evening, it should have no return air or no outside air, run on 100% return air, so you're not conditioning outside air unnecessarily. So even if you're night cycling a unit, it shuts off at 3:30 in the winter time and it comes on if it gets down to 60 degrees at night. When it comes on at night, the outside air damper should not open. And again, it's a real simple item, but it has to be programmed so that the unit only brings in fresh air or outside air during the occupied hours when students are going to be present. And the reason for that is to get the CO2 levels down for the students, right? They can learn better, it's thermally better, it's fresher air, higher percentage of oxygen, the CO2 levels don't build up. OSHA has a threshold of about 1,000 parts per million. Normally, there's a control sequence that when you hit about 800 parts per million, you bring in more fresh air so that you don't have a problem with that. Resetting duct static and discharge air static based on the controllability of the building automation system. The building automation system can look at the demand and say, no, we don't need 55-degree air. It can warm up to 57 or 58 degrees and save energy. It's that powerful, and that's what you have to take advantage of. And again, if you have any simultaneous heating and cooling going on, eliminating that is a very low cost, cost-effective way to make the equipment perform better, last longer, and save energy.
Thank you so much, all three of you, for coming and talking to us tonight. We really appreciate it.
Okay, thank you. We appreciate the opportunity.
Thank you for watching this video. I hope it has provided both the knowledge and inspiration to help you green your school. Good day.